The last of the three forms to be able to graph is in standard form, and it looks like this. Y equals ax squared plus bx plus c. And this is actually the form that you want when you're solving quadratic equations using the zero product property. You want this to equal 0 in order to solve. So the things that you want to pull out of that are the vertex, which you've practiced today, and the formula for the vertex that you want to memorize, because this is the fastest way to graph this, is that for the vertex, the x-coordinate is, you use this formula, it comes from completing the square, and we'll get to that. It's negative b over 2a. So that's the x-coordinate. It's negative b over 2a. And for the y-coordinate of the vertex, you just plug in whatever answer you get for the x, you plug in to get y. So you're going to get some answer for x, you plug it back in to get y. The axis of symmetry, AOS, is going to be x equals that same thing, negative b over 2a. You don't have to compute it again. You already found it. It's always the x-coordinate of the vertex. And here's the big advantage of standard form. You'll like this. You probably saw it today. The y-intercept, you can just look at it and pull it out. You don't have to plug anything in or do any work, because the y-intercept is c. The y-intercept is c. Do you know why? Can you tell by looking at it how come that happens? What do you, yeah. Good. No, when you plug in 0 for x, these go away, they disappear, and you just get c. Y equals c. To find the y-intercept, you let x be 0. That will just go away, and you'll get c. So the y-intercept, all I'm going to say about it is the y-intercept is 0, comma, c. Whatever this number is, you just graph it, or you name it, or you see it, and it's that quick. So let's look. Let's put an example of this in your notes. So let's say you have this equation. Y equals x squared minus 2x minus 1. So we want to do negative b over 2a. So for the vertex, x equals negative b over 2a. So you do the opposite of b. B is that constant, the middle constant. The opposite, negative b, right? Opposite. So it's 2 over, and then 2 times a. What is a? Yeah. Yes, good. You don't see it. It's 1. 2 over 2 is just equal to 1. So that's the x-coordinate. To find the y-coordinate, to find the y-coordinate of the vertex. So all of this is for the vertex. That would be the harder part. That's the more time-consuming. You have to plug in x equals 1 into the original equation. So y equals, it's like you're doing a table of values and you're plugging in 1 for x. So you would do 1 squared. We should always parenthesize when we plug in, minus 2 times 1 minus 1. Yeah, order of operations, exponents, then multiply. So 1 minus 2 is negative 1, minus 1 is negative 2. So that would be the most work is finding the vertex when it's in standard form. And we know it opens, we can tell that a is positive, it opens up. We can start graphing this. So we have, it's at 1, negative 2, which is 1, negative 2 is right here. So we know 1, negative 2 is right here. We know that the axis of symmetry, again, is what? The equation for the axis of symmetry is? Yeah, not 1, be careful, it's x equals 1, because it's a line. The axis of symmetry is in a line, and that has to have a whole equation. So, and then we just use the y-intercept, it's right here. So this thing, this constant, is the y-intercept. So I'm just going to graph that. On the y-axis, negative 1 is one of the points, and so I get to reflect it over on the other side. And there's my